Howdy, partner. Let's get going on example 5. So example 5 is going to be a little bit different because if you guys notice, the A value is not 1. And what we do when we're in vertex form, it's not anything different than how we dealt with an A value that wasn't equal to 1 when we were completing the square. But we just have to do it a little bit differently since we have a y in our equation. So don't worry, it's the same thing. We just have to do one teeny tiny bit thing different when A is not 1. And it's going to be slightly different from what we did when we completed the square. But it'll be okay. I pinky promise. Okay, let's get started. So the first step, we want all the terms without x on the one side and all the terms with x onto the other, which means that negative 18 needs to move over. So I'm going to add negative 18 on both sides, or I'm going to add 18, sorry. Okay, negative 18 plus 18 cancels and turns to 0. These two are not like terms, so I'm going to write y plus 18 equals, so we have 2x squared plus 12x. Okay, so my A value is currently the number in front of the x squared, which is a 2. So, oh no, A is not equal to 1, which is bad, okay? It's not equal to 1, so that's not a good thing. Okay, so again, like we did when we completed the square, I'm going to be forcing that value to become a 1, whether or not it wants to be. But we are only going to be working on the right-hand side of the equation. Okay, so before when we completed the square, we had to divide every single term by that 2. Okay, technically you can do that. It'll just be harder to get your equation to look like vertex form. So what I'm going to show you is a way that you can make A be 1 and it'll kind of look more like vertex form. Okay, so we're only going to look on this side of the equation for right now. So what I'm going to do, I am going to divide both of these terms by the 2, and what I'm going to be doing is factoring out the 2. Okay, so it's going to be kind of like when we factor out the GCF. Okay, so what's going to happen, I'm going to write like this. Okay, I'm going to factor out the 2, so I'm going to write 2 in front of the parenthesis, and I'm going to divide both of these terms by 2 and write what's left over in here. Okay, 2 divided by 2 will cancel out and turn to 1, so I'm left with 1x squared, and then 12 divided by 2 is 6, so plus 6x. Okay, so I have not changed the equation at all. If I were to redistribute the 2 back, I would end up with this equation. Okay, so now that my A value is 1, now I can look inside of my parenthesis and force this quadratic to become a perfect square trinomial. So I'm going to do that nifty formula to force this equation to become a perfect square trinomial. So we're no longer looking at these equations. Okay, so 6 is our new B value. I'm not going to look back to when B was 12. Okay, so keep that in mind. So now we're going to do B over 2 squared. And we're looking at the new B. New B, get it? Anyways, so, well, it's B over 2 squared. Which is 6 over 2 squared, so whatever. Okay, so we have B over 2 squared. Our B is 6 now, so that is 6 over 2. Okay, and 6 over 2 is 3. And 3 squared, 3 times 3 is 9. So I'm still going to be adding this magical number onto both sides of the equation, but it's going to be a little bit different because I'm going to add it to the inside of my parentheses. So I'll talk about that in a second. So we're going to add it onto both sides still, but something strange will kind of happen when we add it to this side. So I'll talk about that. So this will equal 2, and I should have made this bigger. Gee willikers, Miss Long. Get it together. All right, so 2 times x squared, so 1x squared or just x squared, plus 6x, so plus 6x. Well, I'm actually going to leave it in this color. Sorry, guys. Okay, and then I'm going to add the other color in the red. Okay, so plus 9. Okay, so we need to add the same number to both sides of the equation, okay? So we added the 9, but we added it inside of the parenthesis. Guys, so if you notice, there's a 2 on the outside of this parenthesis. So if you are going to distribute this 2 back through, if you multiply the 2 to the 9, what's 2 times 9? It's 18. Okay, so I didn't just add 9 on both sides of the equation. I'm actually adding 18 onto this side of the equation. Okay, so remember, we got to keep the equation balanced. This 9 actually really isn't a 9 because when you multiply the 2 back through, it turns into an 18. So I have actually added an 18 technically to this side. This is secretly an 18. Okay, so since the number only happens when it's in a parenthesis with a number out in front. Okay, so I'm not going to add 9 to this side. I'm going to add 2 times 9 on this side, which is 18. Okay, so just be careful. This is the one part that's a little strange and a little different when we complete the square and try to write standard form in vertex form. Okay, so just be careful, you guys. If that doesn't make sense, please make sure you ask for help. Okay, so now we're going to proceed like we normally do. So everything from here on out is the same. So if you want to take over from here and do the rest on your own, go for it. Okay, so next up, I'm going to combine these two bad boys. 18 plus 18 is 36. So it's y plus 36 equals 2 times. So now I'm going to force this side to become a perfect square trinomial. Okay, so I'm going to do my shortcut down here. I'm going to square root the first term and the third term. Alright, so the square root of the first term is x squared, which is x. And the square root of the third term, again I'm looking in here, is 9. Which the square root of 9 is 3. And then, don't forget you guys, you take the sign of the middle term, so I'm going to add. Okay, so now I'm left with y plus 36 equals 2 times x plus 3 squared. Alright, so if you guys see, it's now kind of starting to look like vertex form. So that is why we kind of have to complete the square like this. Instead of dividing 2 to every term, we factor it out because that's kind of like what the a value looks like. Okay, and then we need to keep things in a parenthesis because vertex form has a parenthesis. So that is kind of why we do things like this when you're completing the square to write standard form and vertex form. Okay, and the last step, I just need to bring 36 to the other side. So the way you bring positive 36 over is by subtracting it. So I'm going to throw that bad boy on the end. 36 minus 36 cancels and turns to 0. So I'm left with y equals 2 times x plus 3 squared minus 36. Look at that vertex form. Nice. Okay, and now that we have vertex form, I can answer the nifty questions and draw a brief sketch. So I'm going to rewrite this up here for our vertex form. Okay, so vertex form is y equals 2, whoa, sorry guys, and then x plus 3, and then on the end, I'm going to have a minus 36. Sorry, that's a really bad 6. Okay, so that's vertex form. Okay, so for my vertex point, the h and the k, don't forget, on the h you gotta flip that sign or think the opposite. So since I have a positive 3, that means h is going to be a negative 3. And then my k, I just bring on down, so negative 36. Okay, so I'm going to go ahead and plot my vertex point. Okay, I kind of did a sketch like this now, so we're going to go left 3, so negative 3, and then we're going to go down to negative 36. Now, guys, this is a sketch. It is not an accurate graph. So, if you don't want to, I'm not going to make you like draw out 36 tick marks down, okay? We don't got time for that. Guys, so I just did like 3 tick marks, and then I did a dot, 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 and then I did 36. So, again, it's approximated. It's not perfect. If it really irks you and bothers you that we did that, yes, you can draw 36 tick marks if you want. Okay? But again, mathematicians are lazy, so, you know, if you want to be a mathematician, that's how you do it. But anyways, the A value is the number out in front, which is 2. And 2, is that positive or negative? It is positive, so it's greater than 0, which means we have a positive happy graph, which means this graph has a minimum, so minimum. Okay, so when I draw my graph, it's going to face up like the happy face. And again, it's just a sketch, so just do your best. So it's going to be something like this. Mine looks really bad. Hopefully yours looks better. And my graph's name is going to be, let's see, I'm going to name it William. I like that name. Alright, don't forget to name your graph something. It deserves a name. Don't forget that. Okay, well, nice job, you guys. Example 6 is pretty much the same as this. We're going to have a problem where A is not 1. So it's going to look very much like this. So if you thought you understood what I was doing and you want to try example 6 on your own, do it. Otherwise, follow along with Miss Long on example 6.